Hello, today we're going to talk about the first pair of motion graphs. When you are working with graphs in motion, you will basically have either distance time or displacement time graphs, velocity time, speed time graphs, or acceleration versus time graphs. Today we will look at the first pair, distance time and displacement time. What do we mean by distance time or displacement time? When we say distance time or displacement time, we mean that the distance or the displacement will be in the y-axis, and the x-axis will be the time. So it means when we're talking about distance time graphs or displacement time graphs, this is the y and this is the x-axis. Okay. Um, what is the difference between a distance time and a displacement time graph? Okay, remember that displacement is a vector which is a vector which is associated with velocity, which is another vector, and distance is a scalar quantity. It is paired with speed, no, I wanted to say here, this is scalar, and it is related to speed, which is also a scalar. So from a distance time graph, you will never be able to get velocity. Okay, displacement is associated, or you can obtain velocity from a displacement time graph, and you can obtain speed from a distance time graph, but you can't obtain velocity from a distance times graph because you don't have the information. Okay, the other difference is, imagine you're in point A and you're going to move from A to B to C to D, and imagine each line is 1 meter. So if we move here and then here, here, and then here, what has our distance been? Well, 1, 2, 3, 4. We've moved in as a distance 4 meters. But what has our displacement been? Displacement is the final point minus the initial point. Our displacement has been 0 because we haven't moved. We have ended in the same place, so that's 0 meters. So that is an important difference, especially for our graphs, because it basically means that the distance always increases, but the displacement can decrease because you can have a positive displacement moving positive. So for example, from left to right is what we normally consider positive, and we can have a negative moving negative, so from in the other direction, from right to left. Okay, so distance time graph will always be increasing. At displacement time graph, we could have our increasing or decreasing lines or curves depending on what we're going to look at now. These are the differences between the two graphs. And one, what we can obtain from the displacement, we can obtain vectors, we can obtain velocity. From distance, we can obtain speed, and that displacement can be increasing and decreasing, but distance is always increasing. Okay. But from now on, we can work the same with one graph or the other. So let's consider the equations of motion. I'm going to write them without vectors, but I could write them with vectors. So the equation of motion of the displacement says that displacement equals the initial starting point plus initial velocity times t plus a half at squared. This basically gives us two options which we can see very clearly in our graphs. If a if there's no acceleration, if a equals 0, this means that the equation we're going to have is this, which, as you know, is a straight line. So anytime you see a straight line in a I'm going to write this down as important, straight line in these types of graphs means no acceleration. Okay, it also means that if it's a straight line, the y-intercept will be our starting point as 0, and it also means that the slope of our straight line is going to be u. So that's going to be our velocity or our speed. Okay, so you can obtain the velocity or the speed through the slope. Okay, when it's a straight line. Okay, so what cases are we going to have then? Three major ones. The easiest one is when the slope is 0. Okay, so this means slope is 0. So in the case of a straight line, I mean, so the velocity is 0. Okay, so that means this is stationary. It's not moving. It's at the same point throughout time. Okay, so the next case we could have is a straight line, which could be if it starts here or here, the starting point could be our point of origin, but we could have also something different. Let's with a greater slope, for example, and this over here would be, it means it's starting at a different point. For example, it's starting it's starting at plus 1 meter, plus 1 kilometer, or whatever. Okay, so that's our starting point. And the slope of this straight line, sorry, are the velocity. So if we have v1 and v2, v2 is greater than v1. Okay, be careful, because if we have and this is the same case, if we have a displacement time graph, in a distance time graph it will always be increasing. In a displacement time graph we can have this, which means negative velocity, but this is a constant velocity. It's not decreasing velocity. Careful. In both these cases, and the one below, v1 is constant. What is increasing is the displacement. v2 is constant because it's the slope. Here v3 is constant again, okay, and it's just negative, so it means it's going in the other direction. Okay, so it's advancing. Let's say this object is advancing from kilometer 100 to our point of origin. Okay, it is at a constant velocity, but it's the velocity is not decreasing. What is decreasing is the displacement. Okay, and the next case that we can have is when it's not a straight line, when it's a curve. Okay, so this means that the acceleration is not zero. Okay, so when it's not zero, the equation that we have is this one, which as you see is a parabola. Okay, so remember that a parabola can be written as y equals a plus bx plus cx squared, and that's a parabola. Okay, so if it's a curve in a displacement or a distance time graph, it means that you have acceleration, that the acceleration is not zero. In the other straight line graphs, uh, here acceleration is zero, acceleration is zero, and acceleration is zero. But in this one, it's not zero. Okay, and you can have obviously a positive acceleration or a negative acceleration. Okay. Be careful with this in a displacement time graph again, because as you see, what you have to take a look is how the slope changes. Okay, so here the slope is increasing. Okay, so that you have an acceleration, and here the slope is increasing too. Okay, so in both cases you're accelerating, you're not decelerating. Okay, um, if we had something like this and then this, okay, then here you would be accelerating and then here you would be decelerating. Okay, so to always take a look at the slope. Here you're decelerating and here you're accelerating. Don't take, don't look at the shape, only look at the shape to see if there's acceleration or no. So straight line means no acceleration, a curve means acceleration. But then look at if the slope is increasing or not to see if it's accelerating or decelerating. Okay. So for example, we could have, I'll give you an example. We could have something like this, and then we could have a straight line, and then we could have something like this, and then a straight line here. Okay, so we can clearly see that there are various cases here. From here, we could divide it like this, and maybe here. Okay, so in this area here, the slope is increasing, so it's accelerating. It's a curve, so the acceleration is not zero, and it's accelerating because the slope is increasing. In this section over here, it's a straight line, so there's no acceleration, and the velocity is constant. Okay. In this section here, you had a slope that was going like this, and then the slope is going downwards. Okay, so in this section here, you're decelerating. And you can know that there's acceleration because it's a curve, so a is not zero. Okay, but the case if it's accelerating or decelerating, it's because the slope is changing. If initially it was going downwards, this means it's the acceleration. But as you see here, if it was going upwards, when it goes down, it means decelerating. But if it was going downwards, like the case on the right, okay, this section over here is accelerating. Okay, so this section over here is accelerating. Okay. So, and then the last part of this graph, we can have another straight line. Here, there's no acceleration because it's a straight line. It's a horizontal line, so the velocity is zero, so it's stationary. Okay, so these graphs are very easy. You just have to take a look at if it's a straight line, which means that there's no acceleration, or if it's a curve, that means that there's acceleration. If it's displacement versus time, it can go up and down. If it's distance over time, it can only go upwards. And then if to know if it's accelerating, decelerating, if it's a curve, take a look at the slope to see if it's in each point it's increasing or decreasing. Um, then, okay, and the last part that we can be asked in this type of videos, we could be asked about two types of velocity. The average velocity and the instant velocity. And the difference is very easy. When we're talking about average velocity, imagine you're going on a trip uh, from one place to another. It takes you 2 hours, and to know your average velocity, you're going to divide the final point, the final displacement, the final point you're at, minus the initial point, initial point, and divided by the time taken. So, for example, you could have done something like 110 kilometers per hour if it was a 2 hour trip. Okay, but this is the average velocity throughout the whole trip. But as you know, it doesn't mean you've been going at 110 kilometers all the time. Sometimes you could have gone slower. Sometimes you can go faster. And sometimes you can even be in a traffic jam and stationary. It means that you're calculating more or less the average velocity that it would take, or the velocity that you would have to maintain to uh, travel that distance in that time. Okay. Instant velocity is the velocity at a specific point. Okay, so if we are looking exactly at what velocity we were going when we passed whatever town or into a tunnel or whatever, that instant velocity at that specific point of time and space, that's the instant velocity. Okay, if we are looking at something, a graph like the one we saw before, okay, uh, we could calculate the average velocity, for example, from the origin to A, or even from whatever point that they can ask in the exam, from B to A. And so we would have to see what is the distance in A and the displacement in B, and we would do dA minus dP divided by time in A minus time in B, time taken. Okay, so that would be the average velocity. But if we wanted to calculate the instant velocity at point B or at point A, we would have to draw a straight line which would be tangent to the curve at that point, and then with the straight line, get 2 points of that straight line and do the slope, which you remember was y2 minus y1 divided by x2 minus x1 if we consider 2 points x1, y1 and x2, y2. Okay, so we create a tangent at that point. For example, we create a tangent at A, and we want to calculate the slope of this uh, straight line, or of this straight line, and that would be the instant velocity at point A and point B, and they will be different, okay, because as you see, the speed has been changing because the slope has been changing, okay. So you could be asked in the exam for any of these two velocities. Again, as a summary of the distance or displacement time graphs, remember that what you have to take a look at is the if it's a straight line or not, to see if there's acceleration or not, and then to see what is happening with the velocity or the speed. Take a look at the slope of the curve, of the straight line. Remember that you cannot calculate the velocity of something like this, okay? Because the velocity is changing as it's a curve. The velocity, it has a lot of instant velocities, but it's not constant. You can only calculate the slope or the velocity when it's a straight line. Uh, if they're not asking for a specific instant velocity, okay. When they ask for the velocity at that in a range, you can only calculate it for a straight line, okay. So we will look next to the velocity time graphs and the speed times graph, which again are a bit different from these ones.